Welcome to my film about the endless year. This is going to be the process of how a wave is formed from its birth to its death when it reaches the shoreline. It can first start off with the distance from the Earth to the Sun. This is around 149.6 million kilometers away. With the Earth not getting heated evenly due to the Earth's axis, the warm air is mainly on the equator and slowly growing cooler as it goes to the poles. This then means that the warm air at the equator travels around 30 degrees north when it then cools down and sinks back to the surface, returning to the tropics. This is known as the Hadley Cell, the first cell formation within the three convection cells. The other two are called ferrule cell and polar cell. The next one in the formation is the ferrule cell. This is the middle ground of the Hadley and polar. The ferrule cell is thermally indirect as the two other cells power it alone, with the rising of warm, moist air. Lastly is the polar cell. This is much smaller and thermally direct, as the cold air sinks at the North Pole before it flows south at the surface. This then means it is warmed by the contact with the land/ocean, where it then rises. The three cells are also repeated within the southern hemisphere. But within these areas where there is cool air, this means it is a lot denser and falls to the surface of the Earth. This in which creates an area of high pressure. The global wind system is created by the air blowing from areas of high pressure to areas of low pressure, this creating the Coriolis effect. As within the northern hemisphere, the Coriolis effect deflects to the right, whereas in the southern hemisphere it deflects to the left. Within this, the ocean also helps with the redirecting of energy of the sun by its own currents, transporting the warm water polewards and the cold currents taking colder water to the lower latitudes. As the Earth is covered around 67% of the water, the oceans then receive 67% of the sun's energy. The oceans hold onto the heat with a much longer than the land. So this then moves the heat around the tropics to higher latitudes, within the ocean currents transferring around 35% of the global heat. The currents that flow away from the equator are classed as warm currents, what have less salt within them, what then makes them less dense, whereas the cold currents are saltier, making them dense. Waves are mainly the product of wind, on how they are produced far out within the ocean. For local shore winds can also produce waves, but they can destroy the quality of breaking waves. An onshore wind typically creates choppy and bumpy waves due to the push in the direction of the wave. This makes it unstable. An offshore wind is sort of like the counterbalance of this, as the swell comes from miles out within the ocean, with the ground wind working as a pause hold effect on the wave, pushing against it, which is allowing a longer unbreakable wave to be created. The theory of how a low pressure system is responsible for the creation of good strong waves, as within deep low pressure systems the wind speed is greater, this meaning that more waves are generated by power of gusts. This then creating the friction of wind to sea, as the creation created by the wind helps with the form of energy waves that travel miles on miles until they finally meet obstacles that are usually coastal areas. Low pressure winds keep blowing over the surface of the ocean for a long period of time. With this, the swell will be bigger because the wind energy is being accumulated within the wave being produced. So how does an ocean wave get to be a surfing wave? Well, we've just described the birth of the swell, but there is a significant distance for waves to travel. For example, oceanic waves may have to travel a long journey until finally reaching the continental beach, as well as these waves being affected by various things within the ocean floor. If a wave can travel without hitting any obstacles through deep water areas, they tend to reach a beachfront with a large amount of force. as when the wave reaches the shallow water, they tend to slow down. Wavelength is shortened and the crest of the wave grows, this meaning that the wave height rises. So as the wind crosses the ocean making friction, the friction is acting between the water and air, this producing a turbulence in the air close to the surface of the water, while it is also transferring some of the air's kinetic energy into the water. At the start, the waves are small. The way that it grows is controlled by how much energy the wind has transferred into the ocean. There are three ways the wind controls how the wave formation happens. One is by wind speed, as this means more energy that will produce larger waves. The second is the length of time the wind blows, as this produces stronger waves. The other is fetch. This is classed as the length of water the wind has blown over. Longer fetch means more transferable kinetic energy that equals stronger waves. Waves are like any other. They have several properties, such as the crest and trough of the waves show the highest and lowest points. The amplitude of the wave is the height of the crest. This is above stationary water, but this does not mean it's the wave height, as the wave height is the vertical distance between the crest and the trough. The wavelength is the horizontal distance between the two crests or troughs. The motion of a wave is where the particles of a wave moves through them. As the particles is related to the ratio of the wavelength to the water depth within the much deeper water, the wavelength particles follow almost closed circular paths. This path depends on the wavelength and depth of the particles. When the water gets shallower, the waves will get bigger, and some of the energy the wave have been carrying finally makes it to land. So as this reaches shallower water, the wave is forced to slow down. As the wavelength decreases, the height increases. As the wavelength decreases and its height increases, this is called shoaling. The wave height can only increase so far, however. Above a height of around 1/7 of the wavelength of the wave becomes unstable and it will break. Depending on the type of wave it is, when it breaks on the coastline, it can be classed as either a constructive or destructive wave. A constructive waves have a long period when they break on the beach. They have a strong swash and a weak backwash. Destructive waves are the opposite of them. They have a short period of time. They tend to be steep and form during storms. When they break on the beach, they have a weak swash but a powerful backwash. This then means destroying the beach. Along with this, we have the likes of wave refraction, diffraction, and reflection. A wave refraction is the slowing and bending of the waves in the shallow water. A wave diffraction is the propagation of the wave around an obstacle. Wave refraction occurs when a wave bounces back from an obstacle they encounter. Reflecting waves can cause interference with oncoming waves, creating standing waves. There is also two types of wave breaks. You have a plunging wave and a spilling wave. A plunging wave breaks violently against the shore, leaving the air-filled tube or channel between the crest and the foot of the wave. Plunging waves are formed when the wave approaches the shore over a steep slope bottom. Spilling waves occur gradually on a sloping ocean bottom. The crest of the spilling wave slides down the face of the wave as it breaks onto shore. After these other two, you also have a surging wave. This is a lot more powerful and is more common within winter seasons and stormy weather, as it is a very destructive wave. The beach profile is made up of several things. This includes a high tide level, a low tide level, a beach face, a longshore trough, a longshore bar, a breaking zone, a surf zone, and a swash zone. These three zones break down the water edge of the sea, and you will more likely see surfers within the surfing zone than in the swash zone, as the surfing zone brings more of a peak to the wave than a swash zone. A swash zone is more classed as the white water. You also have the backshore and foreshore. These are another classification of whereabouts on the beach are. The backshore is more on the high tide level, whereas the foreshore is more to the low tide level. There is also the berms. These are all the classifications of the beach that you can see on an everyday basis, even though you don't take much knowledge. So this is my story of how a wave is gone from birth to death within the process of several steps. I hope you enjoyed this video and it was informative, and thank you for watching.